server, and we talked about static web pages. And static web pages are the kinds of pages that we've developed so far in this class. When I say they're static, I mean they don't change on their own. All right. In other words, someone would have to manually change them for the content on the page to change. Which means that if you came back and looked at your very first homework assignment, it would look exactly like the last time you changed it today. All right. And we use HTML, CSS, and maybe some JavaScript to create this. Our focus in this class has been HTML and CSS. But then we came to the conclusion that a lot of the web doesn't work exactly like that. All right. For example, if you do a Google search, do you get the same results every time? No, of course not. You get different results based on a number of different things. You get different results based on, for example, where you live. So if I Googled Italian restaurants here, I would get one set of responses. If I was in Los Angeles, let's say, and I Googled Italian restaurants, I get another set of answers. All right? So obviously there isn't anything static about that. In other words, the search results change. Even if you Google the same terms, they change depending on your location. What's more is if I were to come back, say, 6 months from now and repeat that search in both places, I'm liable to get a different set of results. Because, again, new restaurants pop up all the time, old restaurants close, and so on. Lastly, of course, and probably the most obvious one, is if I search for something else, I'll get a different set of results. So if I do a Google search for French restaurants, I won't get the same as for Italian restaurants. So therefore, something more is going on than our plain old static HTML. All right? An analogy I give sometimes is that static HTML, the web server works much like a server does in McDonald's. All right? You go into McDonald's and they greet you and you order a Big Mac and fries. What does the server do? The server turns around and delivers you something that's already been made and is just sitting there waiting for you, more than likely, right? So they'll turn around, they'll give you the Big Mac, they'll turn around and hand you the fries. So the server's job is easy in that respect. And that's how web servers are with with static pages. Those pages are sitting out there on a web server. You request, or a client requests those. The web server simply finds the files and gives them to you. They're made, just like the Big Mac's made, sitting out there waiting for someone to ask for them, and then they get delivered. Dynamic pages, on the other, are pages that change, and they can change based on any number of factors. That's more like the servers at Subway, right? If you go to Subway, pardon me? Yeah, exactly. I always do this around lunchtime. Yeah. If you go to Subway, first of all, do they have sandwiches pre-made at Subway? No. Why not? Yeah, and okay, to prevent waste. Well, yeah, exactly. And the reason that there's a potential for waste is because no two people's request is going to be exactly the same. You request a Big Mac, you get a Big Mac. It doesn't matter if you got that Big Mac or that Big Mac, right? You're getting a Big Mac. At Subway, though, if I order a turkey club sandwich, I may want it with mayonnaise and banana peppers. Someone else might want onions, tomatoes, and some other kind of dressing on it. All right, different kinds of cheeses, baked versus unbaked, and so on. So in that case, the server doesn't have completed sandwiches. Why? Well, largely because it would be impossible to cover all those situations that you might potentially order. Now, what was that? You wanted turkey with cucumbers and tomatoes? Wait a minute, let me look for it. Look through the bins. Okay, here it is. Boom, give it to you. They're not going to do that. They're going to create it for you on the fly. All right? They're going to ask you some questions like, what kind of sandwich do you want? what kind of cheese do you want? Do you want it baked? What kind of bread do you want? What toppings do you want on it? And so on. So your request is a little more complicated, and the server has to work a little bit harder. But the advantage is then they can give you something that was made just for you. So it can be a lot more flexible than just ordering a Big Mac and getting handed a Big Mac. All right? That's sort of what web servers do in the case of dynamic web pages. Let's carry this analogy through a little bit more. All right? I hope I know when to break this, before we all get too hungry. But the server at Subway, first of all, has a recipe in their mind. They were trained, and there might be written down instructions on how you make a turkey club sandwich. 6-inch versus 12-inch. You put turkey on it and maybe bacon. I don't know. Then you ask what kind of bread, what kind of cheese, and so on. So the server has a list of instructions. The server doesn't have completed sandwiches like they have at McDonald's, but they have a list of instructions on how to create a sandwich. All right? The server also has some ingredients. They have bins of those ingredients, turkey and cheese, different varieties of cheeses, different breads, and so on. So they have some raw materials to make the sandwich with. And the server gets input from you. All right? In other words, you determine what kind of bread there is on the sandwich. You determine what kind of cheese, and so on and so forth. So, let's translate that to our web pages. Because with dynamic web pages, we don't have completed web pages out there. What do we have? We have similar things. We have, first of all, instructions on how to make the web page. All right? That the server is going to execute. We have some raw ingredients that the server is going to take and use in preparing the web page. And finally, we have input from the user, all right, as far as some specifics of the situation. So let's look at doing a Google search. And let's consider maybe what those ingredients are and what the recipe is and so on. So if I go here and I do a Google search for, again, Italian restaurant, notice again that Elyria Italian restaurants in Elyria, and so on down the line. Now, Elyria is a great town. I love this area. I've lived in this area my whole life. But I'm guessing that probably the world's best Italian restaurants aren't necessarily all in Elyria, like the search results imply. Maybe only some of them are in Elyria. All right? The rest are somewhere else. Now, again, if my brother in New York were to do this search, he'd get a different listing. He'd get things in New York and so on. All right. So, let's look at what the different ingredients are in preparing this results. All right? Let's see what goes into the mix in preparing it. First of all, there is my input, the user input. In other words, the fact that I typed in Italian restaurants. That is important in preparing that results page, right? If I typed in French restaurants, I get a whole different other set of results. All right? So my user input is one thing that is a big factor in preparing this page. Another thing that is important is other information that comes with the request. Now, I was trying to think of a restaurant analogy for this, and I really couldn't think of one, so we'll drop the analogy at this point and just speak plainly. In the case of web pages, that other information includes information about your platform. In other words, what browser you're running. Are you running Windows or Macintosh or Linux? All right. and information about your IP address. And without going into the details of it, a web server can look at your IP address and determine, maybe not precisely where you are, it's not like a GPS, but it can determine approximately where we are. So, in this case, it doesn't really matter. You're not going to send someone to a different website if you're an Italian restaurant, if you're a Mac versus a PC user, I don't think. Send the Mac users to the cooler, more expensive ones. I don't know. Maybe. I don't know. But in this case, that information about the request isn't relevant. All right? In other cases, it could be relevant. What if I go to download an application? All right, and the client, the server has both a Windows and a Mac version of it. I guess it could display all of them and let me pick it, but a good web page will be smart enough to say, hey, this person's running a Mac, I'll give them the Mac version. All right, and pages do that. All right. In this case, though, what is relevant is our IP address, because the server can take that and determine an approximate location. It does that by looking at a little database of IPs, without, again, going into details. So that's sort of two of the pieces in piecing together our web page. The user input, our IP address, which they look up in a database, figure out approximately where we are. The other thing is Google's big old database of websites. In other words, continuously, Google is crawling the web looking for additions. So if you put up a website, you don't have to do anything special to get it indexed by Google. All right? Google will find you. All right? Google will find you, and it will add you to the list of database. And specifically what it does is very much a proprietary secret. Right? I mean, that's how they make their money, is by providing the best search engine in the world. All right? So they're not going to tell you details about it. But we can observe some things, and the one thing that we can observe is you don't have to go and register your site with Google. Google is constantly going and updating their records about what websites are out there. All right. Finally, there's the recipe. We won't call it a recipe. We'll say a set of instructions. Another term for this might be a script or might be a program, depending on, the specifics of it, that takes all these different ingredients, just like the server at Subway takes all these different ingredients, and creates as an output an HTML document. So, the web server's job for dynamic web pages is much more involved. All right? It doesn't simply do as is done with static web pages, where the server finds a page that you asked for and sends it to you. The server takes your request, which includes a bunch of information about your request, like your platform, your IP address, and so on. It takes your user input. It then does other stuff based on a set of instructions, sometimes called a script or a program. In the case of Google, it will use an algorithm to scan through the big old database of websites. All right? And it creates an HTML document on the fly just for you. Impressive, huh? All right. And it happens quick, right? Now, here's an important thing to notice. Static pages look like this. The client makes a request through the internet. The request gets to the server. The server finds the HTML document and sends it to the client. just like the server at McDonald's grabs a Big Mac and gives it to the customer. In the case of dynamic pages, certain parts of this diagram are going to stay the same, and certain parts are going to be different. Client still connects to the internet, still makes a request. That request makes it to the web server. The only difference is the web server does a lot of work. It doesn't simply deliver a page that already exists. The server takes the scripts, takes the databases, maybe takes other stuff. Secret sauce, exactly. Along with your user input, which comes in as part of the request, and maybe other info about the request, such as your IP address so it can figure out your location, and so on. It takes all that, mashes it all together, and produces an HTML page. Now, what's the same and what's the different about these diagrams? What's same about it is, from the client's perspective, the client requests a web page and gets back an HTML page. Just like on a very high level, whether you go into McDonald's or you go into Subway, you ask for a sandwich and you get a sandwich, right? Because you can't eat a recipe, you know. You can't, the ingredients by themselves is not a sandwich. The recipe, you can't eat a recipe. Those things have to be processed to create the end results. Browsers, which these clients are, is people using a browser, understand HTML. And when I say HTML, I'm actually abbreviating a little bit because I really mean HTML, CSS, JavaScript, all the files that appear on the web page, the images and so on. But the client, in both cases, gets an HTML document. So in that regard, unless you do a little bit of I won't say reverse engineering because it's not that complicated, but do a little bit of thought experiments, from a user's perspective, it might not be clear if it's a static or dynamic page. All right? Some of them are obvious, right? You know, if we think of, Google, it's clear that they don't have, for every single possible thing that you could search for, a web page sitting there ready, any more than Subway has a sandwich for every possible combination of things that you order. All right, so we can kind of conclude, yeah, they're probably done via server-side scripting. Something like eBay, we can probably conclude that there isn't someone manually changing web pages every time someone bids on something. So those we can probably come to the conclusion that they're done somehow with static. Somehow with dynamic pages. But other ones are less subtle, all right, are more subtle or less obvious. For example, if I went to, let's say, NBC's homepage right now, it would probably tell me what's going to be on tonight, all right? And if I went tomorrow, it would probably tell me what's going to be on tomorrow night. Now, conceivably, someone could be changing that once a day, maybe. But probably not. They probably have a database that keeps their show schedule, and then, automatically that schedule gets updated. So depending on the day that you go to it, that's another factor we didn't list here. Depending on the day you go to it, you get a different TV listing of what shows are going to be on. Now, these scripts are not HTML. These scripts produce HTML. Now, at this point in the class, on occasion, I get people sort of giving me the stink eye and saying, why do we spend 12 weeks learning how to write HTML if you're telling me that much, or if not most, of the web is not written in HTML? Well, it's written in languages that produce HTML. So you need to know HTML whether you're the one that's writing the HTML or you're the one writing the scripts that make HTML. All right? It's kind of like you have to know math whether you do math by yourself or you use a calculator, right? You still have to know like when to multiply and when to divide, all right? If you're going to do an operation, you still have to, even if you're going to use some mechanical means to do the calculation, you still have to know how to do it. Well, if you're going to write a program to create HTML, you need to know what that HTML looks like. So, therefore, you didn't waste your time learning HTML, thankfully. And in fact, many server-side platforms involve a mix of some HTML plus some other components tacked onto them. All right. Now, that's beyond the scope of the class to go more into details, but some of the languages that are used or platforms that are used include the ASP.NET platform, include PHP, Python, Perl, Ruby on Rails, and Java, JSP pages, or Java servlets. All these things are things that can be used to produce HTML pages. It doesn't matter. I won't say it doesn't matter. These scripts can be written a bunch of different ways. All right? They can be written in a bunch of different languages. All these languages, in effect, do the same thing now. They may do them in different ways or whatever, but all of them do the same thing, and that is bring together all this stuff to create an HTML page. Okay. Now, the logical question becomes then, what does this have to do with us in this class? All right? If all this stuff is beyond the scope of the class, and we're not going to write server-side scripting, and so on, then why are we even talking about this? Well, we're talking about this because one piece of the puzzle we are going to investigate. And that is the piece of gathering together data to send to the web server so that the web server has that to work on. So in other words, we said one of the things that we send as part of our request is the user input. And that is integral for the web server's part. We just talked about one case of Google where what we type in the search box, that gets posted to Google server, and Google server then returns the search results. That's just one case of it. In Angel, there's ways for you to tell the web server that you're done with the assignment, and I'm going to upload this file. So you're providing input to Angel. Even before that point in Angel, there's a place for you to put in your username and password. All right? The server has to get that information for you before it can do anything else. In the case of eBay, I'm not real familiar with how eBay works, but I know that you put in, you can enter in a bid on an item. Even before that, you have to register and or log on. All this stuff requires you to enter data. And the mechanism by which you enter data into a web page so that it can be sent to the server as part of the request is through what are called forms. Okay? So forms allow you to do this. So, if we look at a web page like Google, this is a form. This is one of the elements of the form. It's called a text box. It allows you to type in a single line of text. All right? There's also, in this case, there's... Wow. Yeah, that must be a fun place to work. There's a couple of buttons here. And these buttons are sort of, for any Star Trek Next Generation fans, these are the make it so buttons. All right? We're done with our input. Go ahead and do this. Go ahead and do my search. Now, in this case, they've provided two different submit buttons, and that's legal. It'll just do two slightly different things depending on which one you click. In one case, it returns you the search results. In another case, it does the search, just like in the previous case, except it takes you to the top page on the list. So, we type in HTML5. into the form up there, and boom, we get the answer. We get an answer. For this class, we're going to be interested in this mechanism. How we can enter data onto a form, and how we can send that form to the web server. So we're going to be interested in this part of it. How we can allow the user to send input or enter input and then send that input to the server. What the server does with it, again, we're not covering in this class. For your assignment about forms, which I probably will make available soon for next week, I'll provide a server-side script for you. So you just have to hook your form up to my script. All right?
So, box,
yeah, a search box is an example of a form. I'll provide a script for some server-side function. Right, not necessarily a search box or anything like that. All right? So, in demonstrating this, rather than simply talk about forms that aren't attached to anything, I decided to, borrow some of Microsoft's resources. So, we're going to, and the reason I'm not using Google is Google sort of has muddied the water a little bit. I used to use Google in these examples, but the way they handle it is a little more involved now. I didn't want to mess with it. So I'm going to use a straightforward approach, which the Bing search engine uses. So we'll use Bing. 3 times a year I use Bing. Winter, fall, and spring semester, or winter, or summer, spring, and fall semester when I talk about this topic. All right. How does a Bing search engine work? Well, we have our search box. That's a form. I can type in a search item, and then I can click this, and it goes and does the search. All right? So that's how that works. What I've done is I've done a little bit of reverse engineering, and I'll talk about how I did this in a minute. I won't dwell on that unless you're really interested. All right? But I will talk about that in a bit on how I did sort of the reverse engineering to take this and figure out what I needed to do. Because what I did is I wrote my own front end. All right? I wrote my own search page. My own HTML document that is a lot plainer than theirs. All right? But does the same thing. So this web page that I created is hooked to Bing's server-side script. So if I type in HTML5, boom, it calls Bing script and does that. Now, it's not like I'm doing anything illegal or unethical. They invite you to do this, right? That way you can incorporate like some Bing functionality on your own pages. MapQuest does this too, so that you can put a form on your page. At least MapQuest used to. I'm not sure if they still do, but where you can put a form on your page, like how to get to my restaurant. You fill in where you're coming from. You can click the submit, and it'll give you directions to their restaurant. All right. So it's not like it's not like doing anything unethical or anything here. They invite you to do this. All right. So what we're going to do, and the focus of today, is to get down sort of the mechanism by which my form talks to their script. All right? So, let's do an actual. I guess I already had an actual site. Search, rather. Let's look at the URL that got called. In other words, if I'm here and I search for, we'll change things up, CSS3, this is the page that gets called. Let's look at this URL closer. This URL looks different than the kinds of URLs we've seen with static pages. Because, you notice here, there's a question mark. All right? http://www.bing.com/search is the URL, or the main part of the URL. That's effectively the name of the script that we're calling. But notice that there's a question mark and there's stuff after the question mark. What is stuff after the question mark? The stuff after the question mark is all the data that I put on the form. Notice, for example, that what I searched for, CSS3, is called Q. So it says Q equals CSS3. Yeah, it probably means query. But it's really as long as the form matches up with what the server-side script is expecting, it doesn't really matter. Now, notice a couple of things here, that there's some other stuff that either aren't filled in or filled in with stuff that we certainly didn't enter. All right? Those could be things that it uses internally, and those could be things that get passed from that page as what are called hidden form fields. And if there is advanced search, which I remember going crazy looking for advanced search last semester, so I won't look for it this semester, there could be some additional parameters get sent. For example, you could pass maybe what language that you want the search results in. So maybe I want an HTML5 result, but in Spanish. All right, I could specify that, and that would be another parameter. Now, this is the URL from the actual Microsoft form, Bing's actual form and search results. Let's look at mine. So if I go into here and I type that I want CSS3, as it turns out, the only thing really needed to make this work is that very first Q equals. I'll put mine underneath theirs. So, notice how up to that point the two are identical. Really, the only thing their script needs is Q equals CSS3. So the fact that I don't pass those other things takes the default, gives me the answers anyhow, even though I didn't supply them. So those are probably some defaults that are on that string. All right, now let's look at the HTML that produces this. And I'm going to keep this up. I'm actually going to get rid of the actual one. And I'm going to keep mine up so that we can see how my page called their search script and how I passed the data to it. So let's look at the source for this search page. All right. Pretty bare bones. All right. One thing I will say, all right, when I do examples, keep in mind I'm illustrating some very specific point. All right. So in this case, I wanted to keep the example simple. So I got rid of everything except the form stuff. That doesn't mean you should do that on your assignments. All right. The reason I don't go crazy with adding stuff in, at least in this example, is because I want to just focus on the essential parts for this example. All right. So let's look at this. First thing we have is we have a form tag. Think of a form tag as being an envelope that we're putting around all the stuff that we want to send to the server. All right? Now, in this case, we're not sending a lot to the server. We're just sending a value of a text box. That is what we're querying. And also the button is there, right? Because the button says, go ahead and mail this letter. Make it so. Go and send it to the server. If for example, I was doing a page to register for a website where I had a form that had a first name text box, a last name text box, an email address text box, a city, state, zip, all those different text boxes, I still would probably only have one form tag. All right? I still would only have one form tag in this particular example. All right? So it's not like occasionally students get confused and think there should be a form tag for every text box. There isn't. There's one form tag that sort of wraps around everything that we want to send to the server in one shot. It's possible to have a page with two forms on it. If there's two different kinds of data the user can send from the same page. For example, there could be, on a lot of pages that you go to, there's a section to register for the site or a section to log on. That's two different actions, if you will. One is take this data and make a new user for me. One is take this previously entered data and log me on. So in that case, think of it as being two different envelopes, each containing different kinds of information. So it is possible to have two forms on a page. But again, each form tag constitutes a bundle that we want to send to the server as a unit.
So if you were hooking to weather.com,
Mm-hmm.
but it has
All right.
you could put that all in one form. Essentially opening up weather.com, so method get action different. And that would be one form.
Yes.
And would probably return some.
Right. In fact, after we go through this example, let's see if we could reverse engineer weather.coms. Let's go and actually do that example. Now, you were correct in observing a couple things. First of all, the method get refers to how I'm passing the data on to the server. There's two different ways, get and post. For the examples we're going to do, we're going to use get because get passes the data on the query string. Right? In other words, it passes the data as part of the URL. And the reason we're going to do that is that makes it easier to debug, right? Because you can see what data you're sending. All right? The other way, it gets sent as part of the request, but it's not visible as part of the URL. Now, if you're sending sensitive information like password, that probably would be a better way to do that. But in this case, we're not going to be sending anything sensitive, so we're going to use the query string. Action relates to the name of the script on the other end. And I just put action www.bing.com. I actually could put search because if you remember right, that was the URL precisely that they had it. Their page is smart enough if you omit that search to send it there anyhow. All right. So this is the name of the server-side script. Typically, when you're writing this, you or part of your development team is developing both the form and the server-side script. So if you're doing both, you call it what you call the script, and so you'll know what the name is. If you're not doing both, you ask your partner, hey, what are you calling that script that's going to process this data? If you're using another script, like we use Bing script or weather.com, we have to do the little reverse engineering trick that we'll look at in a second for weather.com. Yeah. Well, you would have to have a server-side script at the end, at your end, to do this. Yeah. Unless you wanted to use Bing or Google, because you can do a Google search based on a site. And we could look at, I imagine you could do the same thing for Bing. So you could write that, but that would call their script and search your site. That wouldn't be like your script searching your site. You'd have to have that. All right. So, get says pass the information visibly on the query string. All right. This is the name of the script that is going to handle this data. Q corresponds to what we're calling it on the query string, or what it needs to be called on the query string. In this case, Bing is expecting the term that we're querying to be called Q. So if we call it Q, the script can handle it. If we called it something else, the script's going to not know what to do with it. So let's go just for laughs and go and change this to Z's. So if I do this search now, Bing doesn't know what to do with it, so it just redirects you to the page because we didn't supply what it was expecting. So if we go back instead and make it right, then we're working again. And how do I know that it needed to be called Q.html? Well, because I did a search of my own and I examined that query string and I saw what the name of the script was and I saw what I needed to call it. So, to your point of weather.com, let's go and we'll make a second one of these for weather. Let's go to weather.com and enter a zip. Yeah, this is actually a shortened URL. They're not showing us the actual URL, so we can't do the reverse engineering trick. Let's try MapQuest. All right, they're also not showing us the real URL, or they're passing the data in a different way. So we can't do it with that either. Yeah, we don't. Yeah, yeah, exactly.
Well, let's talk about it.
Probably what they do. Probably what they do is they probably have a little widget on their page to generate the code, and it goes and it generates the code for you. Would be my guess. So that would be my guess as far as that goes. So let's summarize what we have here. The form tag goes around everything that we want to send to the server. In this case, we're really only interested in sending one thing to the server, and that is the thing that we're our search term. All right. The form tag goes around all that. The method, we are going to be using get, and what that does is that passes the data from the form as part of the query string. The action is the name of the script on the server side that is going to be handling this request. Now, the rules are sort of the same as making a link, right? Because this is a different server, I use the full address of it, http://bing.com/search. The first thing is the text box. That's sort of the basic form element, the most basic form element, I guess, is a text box where you can enter in a single line of text. The submit button of type submit is the make it so button. It says go ahead and mail this letter. That is, go ahead and send to the server everything that's included within the form tags. In mine, I think it says submit. Yeah, I could change that, and that's the value attribute. Yeah. That's the value. The type is what makes it a button instead of a text box. All right. The value is the value is the text that's going to appear on that. So there it says go. Exactly, and you can do all sorts of things to style them. Exactly. I want to focus initially on the functionality of the HTML. Probably on let's see, it's Tuesday, right? Yeah, probably on Thursday of this week we will look at like styling these and accessibility for these and some of the other form elements.
Input type,
Mm-hmm.
text, and close.
Mm-hmm.
The implication is
Yes.
so what type text? What could be there?
Well, let me ask you that. Let's think, instead of thinking of the exact syntax of it, what are other things that you've seen on forms on the web that allow you to enter data other than a plain old text box?
You mean like a drop-down?
Drop-down would be one. Check boxes would be another. Radio buttons would be a third. There's actually a couple other. There's a password. In other words, where it doesn't echo what you've typed in. Right? That's a different type. There is, there's one on the tip of my tongue. Oh, a text area, which is not a single line, but a multiple line. So like you could write more free-form comments. A text box is more like just like for a few words, whereas a text area would be you could write paragraphs. And then with HTML5, there's a whole slew of new things that you can put in. Again, not all of them are necessarily supported. Now, here's a nice thing. If you use one of those HTML5 things and your browser doesn't support it, you get a text box. So you're no really worse off than you would have been if you just made it a text box. That's a classic case of what we call graceful degradation before. If it doesn't work, it doesn't break, and it handles it in a workable way.
So, to take the conversation a step further, let's say we had a radio button.
Yes.
Right there where it says input type text equals Q. Input type text radio button 1 equals Q. And so, we send a different input to
Right.
take different form information and send it to the script.
Right. What we'll do is, you're right. Actually, of the controls that we described, some of them are simply different flavors of the input tag. A radio button, for example, is simply an input tag, just like the text box is, with some different attributes to it. A drop-down actually is a different set of tags. And a text area is also a different set of tags. But a checkbox and a drop-down, a text box and a checkbox and a radio button are all done with the input tag. All right. So there's a handful of other things that we can put on there, and we'll explore those next time. So essentially, you're right, but we'll get into the details of that syntax. That's not beyond the scope of this class, but it is beyond the scope of this lecture because I've already gone over time. All right. Other questions? All right. See you over in lab.